Physics 2211 Lab 2 Motion of a Falling Object by Gabrielle Theberge. The introduction of this lab. The purpose of the lab is to observe a falling object and create the computational model based on its motion. And then we're compare two models, one that accounts for air resistance and one that doesn't. And then the zero air resistance model should not predict the motion of the object, as well as the one that does account for air resistance. Key concepts to this are Newton's second law, momentum. A system's change in momentum is proportional to the net force. And then the force of, and certain forces you need to know are the force of gravity, and it's a constant force close to the Earth's surface, and air resistance. Position update formula. The final position is equal to the initial position plus average velocity times change in time. Here's how the code looks with the position update formula. Initial conditions, the mass was about, we just guesstimated, and then we did our velocity update formula based on final velocity is equal to initial velocity plus net force divided by mass times change in time.
2, 1, go.
Here's the tracker model of the paper. We had the system was the paper, the surroundings were the earth, me in the air. Here's the code. Relatively straightforward. This FNet is basically what ends up, what the net force based on the ball. And then we update the velocity based on the net force. And then here's the computational models based on the two different codes. You can see with the just gravity model, it was very curved, but the gravity and drag was very slanted, very straight, very uniform. This is the combined model. We had the predicted in blue, and it looks around the gravity and drag model, and then the gravity model in red, which was a lot steeper of a slope. Computational versus observational model continued. The possible errors for this were the proportionality constant that I chose for the code was incorrect, and then general human error. So what does this mean? Terminal velocity and net force. So the terminal velocity is when the net force is 0 and the model accounting for drag became almost linear, meaning the net force was 0 on the object. It reached the terminal velocity because of the drag. And then what if initial velocity? Terminal velocity will be the same, but they will get there at different times. This is if you apply an initial velocity to a falling object. And then the drag force should be equal to the weight force at a specific velocity, meaning it gets to the terminal velocity. And thank you.